Good day, everybody. We're supposed to find the maximum possible value of a particular expression um, given relatively scant initial conditions. We're only given that the 6 real numbers are positive or non-negative and they sum up to 2. And we want to, we also know this condition right here. We know that there's 3 terms comprised of each of the terms. The products and that their sum is greater than or equal to 5 over 54. Okay, so given this information, which appears to be fairly scant or negligible, not negligible, but not enough, we're supposed to find the maximum possible value of this expression here. Now, this is virtually impossible, in my opinion, unless you notice that this product contains all the terms. This product a plus d, the product of these 3 binomials a plus d times b plus c times c plus f, when you expand that out and it's tedious and error prone, so you get the terms like abc, abf, and ace, the sum, are actually the first 3 terms. You'll notice these 2 underlying objects are the same thing. So yeah, as luck would have it, this part right here, this piece right here is just the second half of all that, you see. Okay, so that's some pretty good fortune right there. Of course, the problem was just designed that way. So we're trying to maximize this object right here, and that's all I did is I just subtracted these 3 terms from the left-hand side. Now, what's next, though? Well, you'll notice that all 6 of the terms add up to 2, but that means pairwise, this product will be maximized when this part right here is, when each of them is 2/3. I guess that's some sort of consequence of the arithmetic mean, geometric mean inequality. But each of these, see, everything adds up to 2. If you add up these 3 numbers, you clearly get 2, which is what they all individually add up to. Okay, so this part maybe is the most obscure part right here. Okay, so that product is just going to tell, what is that, 8 over 27? Whereas that's when this is as big as it can be. We already know when this is as big as it can be, right? Okay, so we'll have 8 over, 27? Minus the given condition 5 over 54, and that's the equality condition is where this maximum is going to occur, right? So that's minus 5 over 54. And, I should point out what I'm writing down is the max of what we're looking for, okay? The maximum value of this guy, and I'm going to write it like this. A little bit of hand waving going on, but hopefully it's enough to convince you. So the max is equal to whatever that is. What do we have here? 5 over 54. 5 over 54 right here, and so that's equal to, oh, that's also convenient, 16 minus 5 over 54. Equals to 11 over 54. Okay. So that's the answer. Or that's the answer I got. Okay. Let me know what I always feel kind of hollow on these sort of problems, like from a sanity check point of view. Like there's not a lot given, right? This is quite a bit though, okay? And then all of these add up to 2, and then this is the big step right here. When you multiply all this stuff out, and you note that this object can be as big as it can be exactly when this one's 2/3, this one's 2/3, and this one's 2/3. Okay, that's I think that's more or less arithmetic mean, geometric mean stuff going on right there. And so so you just multiply this stuff out, you get 8 over 27, and this is as big as it can be at 5 over 54, right? So the maximum value will be what happens when you subtract this. Otherwise, if you subtracted a smaller number than 5 over 54, you wouldn't. You know what I mean? So I think we got it going on, don't we? Okay, so that is all, folks. Let me know what you thought. Thanks for viewing.